Hello. All right. So guys, you may have thought you were going to get a day off today or some such thing. Uh, I've finished marking your tests, and those should hopefully get handed back to this period. They're really well done. But we are going to push on ahead. We're going to start into Unit 3, and we're going to start with a concept that's really important. So make sure you follow along. Today's going to be a handwritten note, so you can get a piece of paper out. And yeah, you'll be able to find this online as well, so you can follow from there. But do try to follow along here. So with no further ado, there we go. This is lesson 3.1, molecular weight. Lesson 3.1, molecular weight. So we are going to get started here. And I want to just start with information that you already know, things that are not at all new. And we know that ionic and covalent compounds are just groups of atoms held together. And for example, we could look at iron 2 chloride, which would be FeCl2. That's an ionic compound, but for every one iron atom in FeCl2, there are 2 chlorine atoms. And of course, we're not limited to ionic compounds. We could also talk about covalent compounds. We could say carbon dioxide. For every one carbon atom, there are 2 oxygen atoms. And there's nothing magical about a 1-to-2 ratio. Those just happen to be the examples that I picked. So with that in mind, today's lesson is going to be about figuring out how much those things weigh. And the periodic table tells us the average mass of an atom of any element. So if we look at the periodic table, it will tell us how much an iron atom weighs, or a carbon atom weighs, or an oxygen atom weighs. That is information that we can find. So knowing that, as we do, we can then use that information to figure out how much these molecules or these compounds weigh. So using simple maths, that's very British of me, but that's okay. We can use this information to find the mass of any compound. All right, and so let's look at a few different examples. Let's start with the easiest example I can think of. let's say, what is the mass of just an oxygen molecule? So, of course, something that none of you would ever forget, because you wouldn't want to reduce me to tears, is you know that an oxygen molecule has the formula O2. And that's because oxygen looks like what? How many bonds does it want to make? Well, oxygen has 6 outer electrons, as you recall, and so of course it wants to make 2 bonds. And so it will do so like this. And more commonly, the further on you go in your chemistry career, the less often we draw it like that, and more often we'd simply draw it like that. Oxygen makes 2 bonds. In short, we can of course say that oxygen gas is diatomic. So how much does this weigh then? What is the mass of that molecule of oxygen gas? And the answer is very straightforward, very simple. And I'm going to show you how we want to write this in addition to everything else. We're going to say the mass, and we're going to use a capital M for that, of O2. And we're going to introduce a term here. We're going to say that this capital M refers to the molecular weight. Or you might sometimes see the term formula weight. We'll talk about the difference between those terms a little later on. But the molecular weight, or the molar weight, that's what we refer to with a capital M. And then often we will just write underneath it in subscript what it is we're talking about. So in this case, we're talking about the molar mass of oxygen. And in this case, we're going to say it is 2 times the weight of just an oxygen atom. And an oxygen atom, if you look it up on the periodic table, depending on the periodic table you use, you may get 15.9994, or if you look to the ones that we gave you earlier, it might just come out at 16.00. Let's go with that smaller number. If you look at the periodic table that I give you usually on unit tests, it just has 2 decimal places, 16.00. We're going to have a whole lesson tomorrow on how we deal with rounding in chemistry. But for today, we'll just say that it weighs 2 AMUs. And if you don't remember, AMU stands for atomic mass units. So each oxygen atom weighs 16 AMU. There's 2 of them in an oxygen molecule. So then you can just do that on your calculator. And when you do so, what do you get? Oh, I don't know. Let's say Haley. And Haley, of course, got it. That is 32.00 atomic mass units. So I hope that makes sense. If every atom of oxygen weighs 16 AMU, then if we have 2 of them, it's going to weigh 32. Straightforward enough stuff, right? Let's try an example and have you do it. And I should mention that up here we said the mass of an oxygen molecule. Here we're going to talk about an ionic compound. And when we talk about an ionic compound, we'll often say formula weight. We say formula weight if it's ionic, and we usually say molecular weight if it's covalent. So in this case, we're going to deal with an ionic compound. So I'm going to say, what is the formula weight third thing I've labeled as an example. And we'll say the formula weight of sodium hydroxide. So pause this video for about 2 minutes and see if you can work that out, just like we did on the previous one with oxygen molecules, which are just made of 2 oxygen atoms. See if you can figure out the formula weight of sodium hydroxide. And when you're done, press play on the video. We'll make sure we're all on the same page and we're all correct. All right, well, first we have to figure out what sodium hydroxide is. And we know sodium has the symbol Na, Latin, natrium. It takes what charge? Alex? Yeah, that's right, +1. And hydroxide takes what charge? Gabe? That's right, -1. If those people are absent, that's okay. And luckily those charges balance, so the formula of this thing is just going to be NaOH. So we know our formula, we know what it is we're looking at here. So now to figure out the formula weight of that, I'm going to say the big M, which stands for formula weight of sodium hydroxide. And what are we looking at here? Well, really we're going to have to look up the weight of sodium off the periodic table, but we're also going to have to look at the molar weight of oxygen, and we're going to have to look at the molar weight of hydrogen. You have to look up all 3 of those. And I think, if I'm not mistaken, I could remember them all. I hope so, because my internet's down, which is why I'm recording this but not streaming it right now. And so I don't have a periodic table on me right now, though I could look one up if I need to. But if I'm remembering right, the atomic weight of sodium is 22.99 atomic mass units. And the molar mass of oxygen to 2 decimal places is 16.00. Your periodic table may say 15.9994. And hydrogen is 1.0079, which if we're just doing 2 decimal places, which is what we'll stick to for now, is I should put AMU. And oxygen is 1.01. And again, if you looked up on the periodic table and had more decimal places than these, that's completely fine. In fact, that's great. And what do we get when we add these together? Well, 22.99 plus 1.01 is 24 exactly, plus 16 is 34, and 40. So we should get a molar mass for this, a big M, of exactly 40.00 atomic mass units. And again, what that means is that a single unit of NaOH weighs 40 atomic mass units, because the sodium weighs 23, the oxygen weighs 16, and the hydrogen weighs 1. Altogether, that gives you 40. We could even say that. So a single unit of NaOH weighs 40 atomic mass units. Just like that. And this really is the whole game. This is it. This is all you need to know how to do. We're going to do one more example together, and then I'm going to give you some homework. And this is a pretty simple skill. Usually with a bit of practice, people get really good at it. But it's also a very important one. So the nice thing to know is that if you get good at this, you will get, like, at a bare minimum, kind of 2 out of 6 marks on every problem in this entire course. Because the first thing you do in every single question going forward pretty much in this course is you're going to do this. It's going to be really important. So if you get good at this, you will always, 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 always have marks that you can get easily on an assignment or a task or a test, and you'll know how to get started every time. So for this question, we're going to find the molecular weight of glucose. And who can remind me the formula of glucose? Phaedra? Yeah, that's right. C6H12O6. You should know that because, of course, at some point in your career, you probably had to build a model of it when you were talking about photosynthesis. If you've taken biology, you've talked about it ad nauseum. Glucose. So there we are. And we are going to find the molecular weight of it. And that just means how much does one glucose molecule weigh? So I want you to do it, and I want you to try to follow kind of the format I followed up here. Now, we already wrote down the formula, so you don't have to worry about this step. But just like we did here, kind of lay it out nice and neatly. Find the numbers on the periodic table, and then work it out. Pause this video, and when everyone's got it, we'll come back together. All right, so for glucose, we're going to say we want to find the molecular weight of it, and we use a big M to represent that. And then we're going to always get in the habit of subscripting things so we know what we're talking about. So we're talking about the molar mass here. The molecular weight. That other term I'm using will make more sense to you in a few days. The molecular weight of this is the molar mass of carbon, but we don't have just one of them. In fact, we have 6 of them, so we have to make sure we multiply that by 6. And then we've got the molar mass of hydrogen, but we don't have just one of those. In fact, we have 12 hydrogens in every molecule of glucose. And then we've also got 6 atoms of oxygen in every glucose molecule. So we have to remember that it's extremely important to not forget that we have more than one of each of these. That's very important. Because CHO is not the same thing as C6H12O6. C6H12O6 is going to be pretty heavy, right? Because we got 6 carbons, those are heavy, 6 oxygens, those are heavy, and then 12 hydrogens, those are pretty light. Maybe pause here in case people weren't able to get this far. You can kind of see, maybe seeing this will jog your memory and get you started. All right, assuming we're all back now, let's start getting numbers here. And again, flying from memory here. But I think we're going to need 6 carbons, so I need 6 of them. And then carbon should be 12.011. And we're just doing two decimal places for today to make life easy. So we'll say 12.01 atomic mass units. And remember, we had 6 of those, so I have to make sure I multiply that by 6. And then we have 12 hydrogens, so that's 12 times 1.01 AMU. Again, very important to remember that there's 12 of them. That weighs more than just one. And then we have to remember that we have 6 oxygens, and they should weigh 15.994, and that rounded is 16.00 atomic mass units. Just like that. And now, knowing that, it's just a matter of doing that on the calculator. And I can't quite do that in my head. I mean, that should be 72 plus 12 is 82, 84, 94, 100, and then plus 5 more, and 5 times 16 should be 80. So this should be like 180 plus how much decimal? Plus 06 plus 12 plus 18. So that should be 180.18. I think. I'm going to quickly check that because I don't trust my mental math. All right, so we would be 6 times 12.01 plus 12 times 1.01 plus 6 times 16. And it's going to want to start here the way this handles syntax. And equal sign, and hey, I got it. Look at that, I'm hired. And so what we can say then is that the periodic table tells us that since each carbon weighs 12 atomic mass units, and we have 6 of them, since each hydrogen weighs 1 atomic mass unit, and we have 12 of them, and then since each oxygen weighs 16, and we have 6 of them, when you put them all together to make a sugar, that should be heavy. It should be 180.18 atomic mass units. All right, so the molar mass, the molecular weight, so the weight of one glucose molecule is 180.18 atomic mass units. And that's that. That's the whole skill. We could do a bunch more examples, but the truth is, they're all going to be the same. They're all just based on the idea that since we know what atoms go into a compound, and since we know how much each atom weighs just by looking on the periodic table, it is actually pretty trivial to then figure out how much that molecule weighs. So I'm going to give you some homework here. I'm going to give you 2 options. First, I'm going to write some homework here and suggest that you do that. But if you don't want to do that homework, you could also load up the app. And I've put some homework up on the practice app that I gave you that you should be able to do that should also be just as useful. So we'll say, find the molecular or formula weight of, and then we're going to give you some options here. Let's say water. And let's say sodium oxide. And that should have a formula of what? Yeah, Na2O. Let's say carbon dioxide. We talked about that earlier. Let's figure out what it weighs. Sulfuric acid. Go. Who can tell me the formula? Yeah, that's right. I'm going to say Jason, H2SO4. And 5. Somebody give me a cation. Yeah, Hannah, that's right, NH4. Ammonium. And somebody give me a anion. Oh, carbonate, great idea, Krish. There we go, NH4CO3. And let's go with a hydrocarbon, something we could combust. This was on the test you guys just did, C4H10. So let's put it there. Why is that 4 again? 2 number 4s. 4 comes before and after 5 in my world. And then we'll say magnesium nitride. Trisilicon octafluoride. And then let's say, nitric acid. And, let's do another nitrate, maybe with a metal. Give me a metal. Somebody said iron. Oh, and iron is multivalent, so somebody give me, we want 2 or 3? 3 it is. Nitrate. All right, so you can do this homework, and I will put the solutions to that homework up online so you can test it. But to give you another option, if you prefer, I've also put some questions on the Teams app. So if you go to Chemistry Practice V2, if you look here where it gives you types of questions, you could pick molecular weight. And it'll make questions for you all day long. And to start, it'll give you the formula, which is nice and easy. It's like sodium bromide there. I'm really going to need a periodic table if we do that. So I've connected to the internet now. So maybe we can get lucky and get this thing. Hey, there we go. I have a periodic table. So like sodium bromide. So if we look at our periodic table here, we would see that sodium is 22.99 and that bromine is 79.90. So we could just say 22.99 plus 79.90 equals, we get 102.89. And if we put that into the question, hopefully it will say, yeah, you're right. There you go. And you'll see here, it gives more decimal places. I've tried to code it to round this to the same number of decimal places you put there. That coding might be a little wonky, so this might tell you that you're wrong sometimes. That's okay. You just keep on plugging, and there you go. And so if you want, you can do that, and that's good practice for you, or you can do the questions that I've given you here. And either or is fine as far as I'm concerned. The important thing is just that you get some practice. So as long as you get some practice, I'm a happy camper. Yeah, and with that in mind, I hope you guys have a great day. I miss you, of course, always, but I'm sure I'm having a good time at Balls Falls, and we'll see you tomorrow. If you've gotten your tests back, please take a look at them. If there's any errors on them, don't be shy. Let me know, especially if I have taken away marks from you that are rightfully yours. I don't like to do that, so make sure you let me know, and I'll return them to you. And as always, if I have given you marks that you didn't deserve, that's on me. That's my mistake, and Merry Christmas. See you tomorrow. Bye.